All right, so we are going to look at the chemistry unit today, okay, and we're going to go over the key things from that unit. I'll talk a bit about how I'm going to ask them on the final exam, and then I'll go through some examples of each skill that you'll need to demonstrate, and then I'll take questions from you guys, okay? In addition to that, I will post today the final exam review package. I haven't posted it on Google Classroom yet, but I will post it today so you can start looking at it. All right, the first thing in the chemistry unit that we talked about was the structure, I've got naming compounds there, but I don't know why. Was structure of the atom, right? I am not going to ask you about people and places on the final exam, okay? Certainly knowing Dalton's atomic theory, that could be important, okay? But I'm not going to ask you what year Dalton came up with that, okay? Those are not important details for a final exam. But understanding, that all matter is made of tiny indivisible particles called atoms, okay? Atoms of the same element are identical, atoms of different elements are different, okay? In a chemical reaction, atoms are separated, joined, or rearranged, and they combine in simple whole number ratios. There's the 4 points, okay? Those are important. Okay, in terms of your understanding of how matter works. And there could certainly be a multiple choice item about that, okay, or two. But again, I'm not going to ask you, who discovered the proton. Okay, that's not final exam. Okay. The next thing, naming compounds. That's super important. And not because I'm going to ask you directly, although there are a few multiple choice questions that are like the ones that were on your unit exam, where I might say, what is the correct name for NaCl? Right? And you have to pick the correct name. So knowing how to name ionic compounds and molecular compounds, ionic compounds with Roman numerals, okay? Ionic compounds with polyatomic ions, that's important. But not for those few multiple choice questions. It's important because it's part of the skills that you'll be asked to demonstrate. Writing and balancing chemical reactions, performing mole equations, all of those things require you to be able to write a chemical formula or a chemical name. Okay? That's the base fundamental skill you need to do that. So probably a decent idea to review your naming rules, okay, for chemistry, for naming compounds. Okay, so writing formula for compounds, I include that with naming. I mean, it is the opposite, but being able to do that is important. Okay, remembering to drop and swap for ionic compounds, using brackets if you need a number on a polyatomic ion, when to use, or what a Roman numeral in the formula would mean, okay, or in the name would mean in terms of putting numbers in the formula, stuff like that. And I'm going to review that in a little bit. Anybody else hear that? It's really loud. Mr. Dickey doesn't have a class right now. It's really strange. It's like haunting. Yeah, what?
It sounds like somebody's talking.
It does.
Sounds like somebody's
I mean, the
watching
wall
a
to this thing is
documentary.
paper thin. We found that out one day. Someone was having a conversation that no one in here should have heard. That's when you go, shut up, pound the wall. Yeah. Okay, lesson 12 is another one to go over, okay? And that is writing and predicting and balancing chemical reactions. Okay, so being able to, identify the types, right? Obviously, you have to be able to do that if you're going to predict one, right? So knowing, the synthesis, decomposition, single replacement, double replacement, and combustion, okay? Being able to know what types, what the patterns are for each reaction, definitely something to review and go over because you will be asked to do those things on your final exam. Okay, there are two reaction problems where I give you the whole reaction and two where I ask you to predict products, I think. Go over that again. I changed it so many times now that it's all blending together. But yeah, you'll definitely be asked to demonstrate your skills related to writing, balancing, predicting chemical reactions. Okay, and we'll go over a few of those here after we get through the review. Okay, balancing, okay, obviously that's part of it when you're writing out a proper chemical reaction. All right, and then mole calculations. Right, there are, moving on two, I think it was two. Okay, mole equation problems. We went over 4. Okay. So being able to calculate molar mass, okay, from a compound's formula or name, okay, that's certainly an important skill. And then being able to use the mole equation to calculate either number of moles or mass. Okay, obviously you never have to calculate M with this equation, you always use the periodic table for that. And also combining that, you may have to use Avogadro's number if they start talking about the number of particles.
Do we have to use the solubility chart?
There could be a multiple choice question involving the solubility chart, yes. All right, so definitely know the mole equation because that's one of the things in the written response. Incidentally, the format of your final exam is exactly the same as the format of all your unit exams. There are multiple choice questions, 50 multiple choice questions. That's 50, 50. Okay, and there are 15, I think, written response. Okay? It's roughly 1.5 times as long as a unit exam because you have roughly 1.5 times as long to write it. Okay? So you'll be familiar with the format. It's nothing you haven't seen before. I'm not suddenly going to throw in a bunch of numerical response or true false or something that you've never seen in my class before. It's exactly the same format as a unit exam. Okay, other important things. Okay, from chemistry. Lesson 4 on properties of compounds, because we did a lab on that, right? We identified all the unknown compounds based on just their physical properties. Okay, so there could be, by could be I mean there are, spoiler alert, some multiple choice questions about properties of compounds. So, you know, you have a green crystalline solid that is highly soluble in water, whose solution conducts electricity and has a pH of 8. The most likely identities for this compound would be A, hydrogen chloride, B, nickel 2 nitrate, C, cobalt 2 chloride, or D, iron oxide. Okay? B, the nickel compound, because all nickel-containing ionic compounds are green crystalline solids that would conduct electricity in solution and would be highly soluble in water. Okay, things like that. All right, so you could have a question like that. So it would be important to review lesson 4 and your lab on properties of compounds. All right, and then, see, Matisse got ahead of me. Solubility and the polar nature of water. Okay, there will definitely be some questions about solubility. So I might give you a chemical reaction and ask you which of the products would be soluble, and then you just have to go to your solubility chart and figure it out. Okay, and understanding the polar nature of water. You had a written response question on that on your unit exam. This time it's multiple choice. Okay, but there are still there's still a little bit of stuff about what a polar molecule is, okay? Those behaviors of a polar molecule, cohesion, adhesion, hydrogen bonding, okay? All of those things that we went over in that unit, okay? There'll be some multiple choice about that. Okay? And that was in lesson 8, so if you're going back in your notes package, that's where you can find that. Okay, in the written response, we've already talked about this, but these are the things you're going to be asked to do. Balance. First 3 items, 1, A, B, and C, are just reactions with blanks. And you have to fill in the blanks to balance them, just like your unit exam. You had 7 on your unit exam. On the final exam, you have 3 to balance. Okay, and then, as I said, you got to predict and balance. Okay, so it was just prediction. That's right. Okay, so then you got 2 reactions, I think it's 2, where you have to predict the products of the 2 reactions. So I give you the reactants in words, and you have to write it out in formula form, predict the products, and balance the reaction. Okay, exactly like you had to do on your unit exam. Okay, and I'll give you more detail on each question on the final exam on the last day. All right, and then obviously mole calculations. Okay, we have to do a couple of those as well. The final exam is pretty evenly distributed in terms of marks per unit, with the exception of Unit 4. Okay, Unit 4 is underrepresented in terms of marks on the final exam because it is so short, right? But in terms of the percentages of the other 3, they're pretty much equal, right? There's more multiple choice for biology than there is written response because it just lends itself more to that. Okay, physics, there's not as much multiple choice as there is written response because it lends itself more to that. So, but the marks are pretty even. I think it's I can't even remember that, but I know they're. I made sure that I checked, and they're within a couple of percent representation on the file. All right. Okay, so if we're naming ionic compounds, okay, so if I name an ionic compound, what are some things I need to remember? What's in an ionic compound, first off? Metal and a non-metal. Which one always gets written first? The metal always gets written first, okay, non-metal second. If I'm writing the name, the non-metal is going to end in "ide." When would I use a Roman numeral in an ionic compound's name? Right. If the metal has more than one possible charge, it is multivalent. Okay? So iron would be an example of a metal that has more than one possible charge. It can be a 2 or a 3. Copper can be a 1 or a 2, and so on and so on. Okay? I have to indicate in the name which charge is being used. Okay? For molecular compounds, okay, in molecular compounds, in order to tell people how much of everything there is, I use prefixes. Why don't I use prefixes in ionic compounds?
Because they have to be balanced.
Right, they have to be balanced. The charges will balance, and there's only one way that sodium and chlorine can go together. So I don't have to say sodium monochloride. There's only one way they can go together, right? Okay, so those are some of the little things to remember. All right, let's see how much we remember about doing this and name those 4. Give you a couple of minutes, see if you can remember how to do this, and then we'll go through them together. All right, so our first one here, we've got MgCl2. Okay, so Mg is magnesium, right? And Cl is chlorine. So we've got magnesium chloride. Do I need any prefixes? Do I need a Roman numeral? No. Magnesium only has one possible charge. It's 2+, so that's all it can be. I don't need a Roman numeral in that one. So that's just magnesium chloride. Okay. What about this one? What's N stand for? Nitrogen. Okay. And there's 2 of them, so what needs to go in front of this? Di. Right, and this stuff is, how many of them? Okay, so Right, so let's have a look at Fe2O3 here. All right, so we got, what's Fe stand for? Iron. What's O stand for? Oxygen, right? So we know we don't put any prefixes in here, but there's another iron oxide, and it looks like this. I can't call that iron oxide and call the other one iron oxide because they're not the same thing. So this compound needs Roman numerals. So I have to figure out which Roman numeral needs to go on the iron, because iron can be a 2+ or a 3+ charge. All right, so here's how I do that. Oxygen is always a -2. So I always look to the non-metal because there are no non-metals with multiple charges. Okay? If there are 3 oxygens in this compound, each of them having a -2 charge, then there are 6 negative charges that need to be balanced by these 2 iron atoms. Okay? Because an ionic compound needs to have an overall charge of 0. That means the positives and the negatives have to cancel each other out. All right? So I need to have 6 positives come from here. What's 6 divided by 2? 3. All right? So each iron must have a positive 3 charge. So this is iron Roman numeral 3 oxide. Okay, so this would be iron 2 oxide, right? Because oxygen's always a -2. That means this iron must be a +2 for them to balance each other out. That would be iron 2 oxide. All right, what about this one with the polyatomic ion? How do I name that? Sodium carbonate. Okay, so I write the name of the metal, same as before. And then if I see that there's more than one atom attached to it, I go to that polyatomic ion table on the top of the periodic table, and I look up CO3, it's carbonate. So I just write carbonate, I don't change its name at all, and I don't need any Roman numerals, so sodium carbonate. All right, is that ringing a bell? Those are the 3 kinds, or 4 kinds, okay, of naming things that you could run into. Okay, possibly need a Roman numeral, possibly have a polyatomic ion, regular ionic compound, and there's only regular molecular compounds, so that's all I need there. All right, if you have questions as we're going along, guys, don't be afraid to ask, or if you want to go over more of those, okay, just ask. This is about what you need, okay, for the file. All right, so here are some write the formula kind of questions. Give those a try. So, lithium nitride, ionic or molecular? It's ionic, okay. So with an ionic compound, and I know it's ionic because lithium is a metal, I write the metal and its charge, lithium's a +1, then I write the non-metal and its charge. Nitrogen's a -3, what do I do with those charges? Drop and swap. Okay, so this will be Li3N. Done. That's all I have to do for a normal ionic compound. Okay, triphosphorus tetrabromide, ionic or molecular? Molecular. It's got prefixes, first off, that's our first indicator. And secondly, it's 2 nonmetals. Right, so that's molecular compound for sure. All right, triphosphorus. Phosphorus is P, tri is 3. Okay, tetrabromide. Bromide is Br, tetra is 4. Right, that's all there is to a normal molecular compound. Okay, magnesium oxide. Ionic or molecular? Ionic. Magnesium is a metal. Alright, so magnesium is a 2+. Oxygen is a 2-. Okay, when I drop and swap, I get 2 and 2. But what should I do with that? Reduce it. 2 and 2 cancel. Right? So I don't need anything here. Alright, if this was 2 and 4, I would reduce it down to 1 and 2. We always reduce if we can on ionic compounds, not molecular compounds. Okay, and then our last one here, copper 2 sulfate. What is the Roman numeral telling me about copper? Its charge. It's telling me use a 2 when you drop and swap this compound. Okay, sulfate polyatomic ion, SO4 with a -2 charge. So when I drop and swap this one, okay, do I need brackets? I don't, okay? I'm not going to be putting a number beside the 4, so I don't need brackets for this one. If I was needing to put a bracket or a number beside the 4, that's when I would enclose the sulfate in brackets and put another number outside of those brackets. Can't remember if I had an example of that or not. I did. That one. Okay. So nickel 2 hydroxide. So nickel is Ni. The Roman numeral is telling me the charge on nickel is 2+. Hydroxide is OH, and it has a -1 charge. Right? So when I drop and swap, I don't want to do this. Because if I do that, it says there's 1 nitrogen, 1 oxygen, and 2 hydrogens. I want there to be 2 hydroxides, because that's really what's happening here. And so that's when I use the brackets. Questions there? Ringing a bell? Right. Do you have a whole bunch of worksheets in your booklet on naming and writing formulas?
Yes.
Do you have keys for those?
Yes.
You do. They're all in the stream way back at the beginning of the year, right? But they're all there, right? I'm not saying do them all, okay? But do a few. It's worth the practice. It's worth the review, okay? And you have keys for them so you can check and see if you're doing it right. Okay. What kind of reaction is that? It's a synthesis reaction. Element plus an element gives me a single compound. Okay. Is it balanced? It's not. All right. If I want to balance a reaction, what do I start with? Yeah, I go with the biggest number. Okay? Right now, the biggest number is chlorine, and it just so happens that's also the thing that's not balanced right now. There's 2 chlorines on the reactant side and only 1 on the product side. All right, now I can't just go and put a 2 here because that changes the compound. I don't want to do that. I just want to change how much of the compound I have, so I put a coefficient. That's a big number in front of it. Now, I have 2 chlorines on both sides. But I also now have 2 sodium on the product side and only have 1 sodium on the reactant side. So what do I need to put in front of sodium on the reactant side? Big 2. All right. Can I put in little numbers? No, unless I'm dropping and swapping. Okay, if I'm dropping and swapping because I predicted the reaction, then I can put them in. Okay, but I don't put them into balance. Okay, I can't change those numbers when I'm balancing. All right, let's, okay, so balancing for this one. Do combustion reactions have special balancing rules?
Yes.
They do. Okay, anyone remember what they are? Always balance in alphabetical order?
And if there's like an even number on the first one, you have to balance it with 2.
Exactly, the rule of 2. If there's an even number of carbons, I start my balancing with a 2. All right. I will need to use both in this reaction because I have an even number of carbons. So I put a 2 there. Now I'm going to balance in alphabetical order. How many carbons on the reactant side? 4. 2 times 2 is 4. So I'm going to put 4 over here. All right, how many hydrogens on that side? 12. 2 times 6 is 12. So I'm going to go over here and go 6 times 2 is 12. Now I can balance the oxygens, and I start on the product side now. Okay, there are 6 oxygens in the water, and there are another 8 in the carbon dioxide. Okay, 6 plus 8 is 14. What times 2 will give me 14? 7. That's about as tricky as they'll get. Okay. I'm not going to put on any of the really, really tough ones like you had on your assignment. Okay, some of those like really challenging ones that didn't fit the mold of the reaction types we went over. You won't get those on the final. get far more standard kind of reactions. All right, see if you guys can balance that. Okay, so what should I start with on that one? Yeah, I'd start with magnesium. Even though sodium is a 3, if I've got two things that are the same number, like tied for the biggest number, do the one with the biggest charge first. Magnesium's a 2+, sodium's a 1+. Okay, the ones with the bigger charge usually have a bigger effect. Okay. So, when we're doing that, I have 3 magnesiums on the reactant side, but I only have 1 over here. So I'm going to need to put a 3 in front of that. Okay, when I do that, okay, it gives me 3 oxygens over there. So I'm going to come back over here and make sure my oxygens work by putting a 3 in front of this. Okay, how many sodium does that give me? 6. So I'm going to go over here and make sure I have 6 sodiums. When I do that, it gives me how many nitrogens? 2. So I go back over. Oh, look at that. Sweet. Okay. Always a good sign if when you get to the end, the last number you put in fixes everything. All right? So that one is now balanced. So it's back and forth, starting with the biggest one. Questions on the balancing? Okay. We didn't get to any predicting, but we will. Okay. How many moles of sodium sulfide are in 250 grams? So write this one down. We'll walk through it together as a review. This is the easiest of the 4 mole equation calculation types. Okay, so looking for how many moles. That's N. The rest of the stuff the question gives me is they tell me the material, which can allow me to calculate the molar mass, big N. Right, I do that by looking at my periodic table and doing the calculations. But the first thing I've got to do is actually write the formula for sodium sulfide. I can't just say there's 1 sodium and 1 sulfur because that might not be true. Spoiler alert, it's not true. Okay? This is an ionic compound. Sodium, which is a +1, and sulfur, which is a -2. Okay, so this is Na2S. There's why it's important to be able to write chemical formulas correctly. You would not be able to get this question right, even if you knew how to do mole calculations, without being able to get the formula right for the material. Okay? So, I've got 2 sodiums, so that means 2 times the atomic mass of sodium, 22.99 grams per mole, plus 1 sulfur, which is 32.07 grams per mole. Plus 22.99. I forgot. All right, 78.05 grams per mole. All right, so there's our big M. Question wants to know how many moles there are. Well, the other thing the question told me was little m, or mass. It told me it's 250 grams. All right, so the mole equation says that number of moles equals mass divided by molar mass. I now have both of those numbers, so all I have to do is plug them into the formula. 250 grams divided by 78.05 grams per mole. Alright, so that's 3.2 moles. Right, so that's the easiest of the 4 types that we went over. Okay, questions on that one? Okay, see if you remember how to do this one. Right? This one here, we're looking for the mass of 11 moles of dinitrogen hexafluoride. Look at this one. So the question tells us that we have N, 11 moles. And then it tells us that this stuff is dinitrogen, N2, hexafluoride, F6. Okay, I don't reduce that because this is a molecular compound. But I do need to calculate its molar mass. So that means I've got 2 times 14.01, so that's my nitrogens, plus 6 times 19.00, that's my 6 fluorine atoms. Right? If I put those together, I'll have 28.02 plus 19 times 6. All right, so 142.02 grams per mole. So now I have big M and I have N. I'm supposed to find the mass, little m, which means I'll have to manipulate the mole equation for little m. So I have to multiply both sides by big M. There's my formula for little m. So all I have to do is go little m equals 142.02 times 11 moles. All right, and my mass is going to be 1,562.22 grams. How important are units? Very important. Don't forget your units. All right. Questions on that one? Right, so the last 2 kinds involve using Avogadro's number. Okay, that's at 6.02 times 10 to the 23. That's the number of particles in a mole. Okay, so this one involves using that. So I'm just going to have you write that down and we'll walk through this one together and then I'll have you try the last one, okay, which is the reverse of this one. So in this question, we're looking for the number of molecules. In order to get the number of molecules, I'm going to have to take the number of moles and multiply it by the number of particles, Avogadro's number, in a mole. Okay, so that's what I'll have to do eventually. I'm not there yet, okay? But eventually that's what I'm going to have to get to. What they're telling me is that the material is calcium chloride, which is an ionic compound. So I got to write the formula. Calcium's a 2+, chlorine's a 1-, so this is going to be CaCl2. I once put a question just like this, it might have even been this exact question, on the final exam, and only half of people got it right because they forgot to drop and swap this. They just went 1 calcium, 1 chlorine, and did the question. Okay? Always make sure you check the formula before you start doing any more calculations for the mole equation. All right, so calcium is 40.08. There's only one of them. And chlorine is 35.45, but there's 2 of them. All right, so the molar mass will be 110.90 grams grams per mole. Okay, so I have big M, and they're also telling me M. Okay, M equals 175 grams. All right, what can I get if I have little m and big M? The number of moles, and that's what I've got to get next. So I'm just going to use the mole equation as it's given to me. N equals little m over big M. So 175 grams divided by 110.98 grams per mole will give me N. Okay, so I have 1.5768. I'm going to keep all those decimals. I'm just going to write 1.58 moles. Okay, now that I have N, I can calculate the number of molecules, because it's going to be the number of moles multiplied by the number of particles in a mole. Okay, that should make sense, right? It's like if I want to know how many donuts are in 2 dozen, I go 2, the number of dozen, times 12, the number in a dozen. Okay, same idea. So, my number of molecules, okay, like we said here, N times 6.02 times 10 to the 23, which is going to be our 1.576 times 6.02. And remember, when you're punching that into your calculator, it looks like this. So I put Avogadro's number in brackets, 6.02. Then I hit the second function, and I get the comma. That'll give me the E times 23. End the brackets. All right, so I'm going to have 9.49 times 10 to the 23 molecules of calcium chloride. Questions on that one? Looking a bit familiar? Todd? Yeah.
How do you get the E?
Second and the comma. Yeah? Everybody else okay with how the calculator works? It's been a while since we did that, so it's perfectly okay if you forgot. All right, I want you guys to try the last one, but I won't show you the answer because apparently I didn't erase it. Okay, we're looking for the mass of 2.5 times 10 to the 24 molecules. So this time they gave you the number of molecules, and they want you to work backwards and get the mass instead. See how you guys do on that. Okay, so let's walk through this one. So we're looking for mass. What we're told is that we have 2.5 times 10 to the 24 molecules. Okay, and we're told it's hydrogen chloride. But before I get to that, I actually want to calculate the number of moles, which I can do right now using the number of molecules and Avogadro's number. Right? And I do that by dividing those two things. I take the number of molecules I have, 2.5 times 10 to the 24, and I divide by the number of particles in 1 mole, Avogadro's number. Oh, times 10 to 23. Right? That will give me my number of moles. So I want to do that operation first. So that'll be, okay, 2.5 E24, whoops, 4. Okay, divided by Avogadro's number, 6.02 E23. All right, so I have 4.15 moles. I'll keep all those decimals in my calculator for later. All right, the other thing the question told me was that this stuff is hydrogen chloride, so I can calculate the molar mass, HCl. Okay, that means 1.01, that's my hydrogen, plus 35.45, 1 chlorine, so that's going to be 36.46 grams per mole as my molar mass. Everybody okay with that? Okay, so from there, I'm now looking for M, and that's where I'll use the mole equation. M equals, okay, or sorry, N equals little m over big M. I've got to manipulate that, like so. Plug in my numbers, 36.46 times 4.15, okay, which is what I calculated before. So that would be the toughest one, because it would have the most steps. So we'd be looking at 151.41 grams for our final answer. Any questions on that? Everybody good with that? Okay. So reminder of how the solubility chart works. Okay, so if we're trying to figure out whether something is soluble, okay, in the first row, it's very soluble. Okay, so if we're looking at, like sodium here, or sorry, we've got like the negatively charged or non-metals up top, right? So if I've got chlorine, for example, sodium would be here in this group, group 1A. Okay, that would be very soluble, but it wouldn't be soluble with lead 2+. Okay, that would be down in this row here. So first row, very soluble. Second row, not soluble. Just a quick reminder how that works. All right, I want to put up a couple of prediction ones because we haven't done that yet. Okay, so I'm just going to put these up. You guys write them down and give them a try. All right, so give those 5 a try. There's one of each type of reaction there. So quick review here. In order to predict the products of a reaction, we first identify the reaction type, use the reaction type's pattern to match up partners, balance. Okay, swap and drop any ionic compounds, look for special elements, and balance. All right, let's have a look at these here. So for our first one, I've got only one reactant. What kind of reaction starts with only one reactant? Decomposition. Okay. So in a decomposition reaction, the pattern is that our compound breaks down into its constituent elements. One of the big things I have to be mindful of in a decomposition reaction is the formation of our special elements, okay, the ones that are colored on our periodic table that come as 2s or 4s or 8s or whatever, okay? So I'm going to have nitrogen as well as fluorine being formed as a result of this decomposition, both of which are polyatomic, are molecular elements, okay? So fluorine comes as a 2 and nitrogen comes as a 2 when they're by themselves. Okay? So now that I've identified those, now I can go back and balance the entire reaction. Pretty much everything's a 2 in here, but I'm going to start with nitrogen for my balancing. There's 2 nitrogens here, so I need to put a 2 here. When I do that, it gives me 4 fluorines so I need to put a 2 here, and now that reaction is done. Okay, predicted and balanced. All right, so one of the most important things, and it's the thing that people forget, is to be on the lookout for the formation of those molecular special elements. Okay, question number 2. What kind of reaction am I looking at there? That's a combustion reaction. What are always the products of a combustion reaction? Right, CO2 and water. Okay, do I need both rules for this one? No, I have an odd number of carbons. All right, so 5 carbons, 5 carbons, 12 hydrogens, 6 times 2 is 12. Now I can balance the oxygens, 6 oxygens here, okay, and 10 here for a total of 16. 8 times 2 is 16. Right. What kind of reaction am I looking at on number 3? Synthesis, yeah. Now, I played the only trick I have in a synthesis reaction on you in this question. What kind of compound am I going to form? Ionic, a metal and a non-metal. What gets written first? The metal does, right. Okay. All right, since it's ionic, I've got to drop and swap it. This is a -1, this is a +1, so that's already fine the way I've written it, Ki. But over here, there are 2 iodines. So I need to go over here and make sure I have 2 iodines. That's going to give me 2 potassium, so I need to put a 2 there in front of the potassium, and now it's balanced. Okay. Everybody all right with that one? Okay. For question number 4, what kind of reaction is that? That's a single replacement reaction. Okay, the pattern for a single replacement reaction is the element replaces the part of the ionic compound that it is like, which means chlorine and nitrogen are going to switch places. So nitrogen is going to wind up alone, calcium is going to end up with chlorine, right? And I've already identified that nitrogen is a special element. That's one of the things I have to do when I'm checking my products. The other thing I've got to do when I check my products is drop and swap my ionic compounds. Okay, so this will be CaCl2. All right, now I've got to balance this whole reaction. The largest number I have is calcium. There's 3 of them over here. So I need to go over here and put a 3 in front of calcium. That's going to give me 6 chlorines. So I've got to go back over here and make sure I've got 6 chlorines. The nitrogens are 2 and 2, so they're good the way they are. Okay. Questions on that one? Single replacement reactions are probably the toughest because they involve having to drop and swap, having to look for special elements. Okay. Our last one is our last reaction type, which is double replacement. In a double replacement reaction, all we do is swap the metals. Okay? So that means that magnesium will end up with oxygen and iron will end up with chlorine. Okay, now the reason I picked iron is because it has more than one possible charge, and this can come up sometimes. I need to know which charge iron has over here so I know what to use when I drop and swap this compound over here. All right, so I've got to do that thing we talked about earlier. Oxygen's always a -2, so there's 6 negative charges. I've got to get 6 positives from these 2, so iron is a 3+. All right, so this is 3+, this is 1-, so I'm going to have FeCl3. This is a 2+, this is a 2-, so that compound is fine the way it's written. Now I need to balance. Okay, so I've got a 3 in front of my oxygens and a 3 in front of my chlorines. Right, so let's look at the oxygens first. I got 3 over here, but I only have 1 here, so I'm going to put a 3 there. Right? If I do that, I've got to go over here and put 3 in front of the magnesium. When I do that, it gives me 6 chlorines. So I'm going to go over here and make sure I've got 6 chlorines. When I do that, it gives me 2 iron. I go back over here, make sure I've got 2 iron. Oh wait, I already have 2 iron. I don't need to put a 2 in front of that. Okay. And my oxygens are 3 and 3, so we're good. Okay, that would be about as tricky as it gets to balance it. All right, that's the stuff we got to remember how to do, guys, for the chemistry part of the final exam.
Yeah.